Hello, everybody. Welcome back to Math 100. This is practice test number 2, the solutions. Okay, so I will be going over those 28 questions on your practice test number 2, and I will again try to do sets of 5 questions. So we'll end up with multiple parts. Okay, so let's get started. And in this clip, we will do questions 1 through 5. Let's start taking a look at these questions now. All right, practice test number 2. And of course, this test will cover chapters 3, 4, and 5. So we have finance, probability, and statistics. Number 1. Let's talk about the difference between simple and compound interest. Most of our focus has been on compound, but you may want to know just a little about simple interest just because it's simple. All right, so we are going to start with a $1,000 one-time deposit. So that means P is equal to $1,000 for the first 3 years. Okay, so let's say 10% simple interest. So what's going to happen? Let's write down in year 0, of course, you have $1,000. Okay, and I don't know how we're going to do this here. After year 1, what is 10%, right? So R is 10%, and that means under simple interest, it is $100 a year, right? Because at this point, we're talking about annual compounding or annual interest rate. And so after 1 year, it's going to be just $100 more. After 2 years, you have $1,200. After 3 years, you have $1,300. Very simple, and that's why it's called simple interest. For compound interest, you start with $1,000. After year 1, what you do is you add 10% to that. And of course, after 1 year, the amount is exactly the same as under simple interest. After year 2, though, okay, this is going to be different because now you multiply 1,000 by 0.10 squared, right? Remember multiplying twice, and this will end up being $1,210. And after year 3, you multiply 1,000 by 1.10 to the 3rd power, and this is 1,331. These are all in dollars. Okay, so you'll see a slight difference between compound and simple interest, and of course the difference will be very dramatic after many years. Number 2, when the interest is compounded at 6% monthly, they don't really mean 6% every month, obviously, right? When they say the APR is 6% compounded monthly, what exactly does it mean? All right, so the APR is 0.06, but it's monthly, so you divide by 12. And of course, this means 5%, not 5%, 0.5%. In other words, 0.5% every month. Okay, so if you multiply 0.5% every month, of course, it becomes 6% for the annual rate. So that's why they call the 6% APR, the annual percentage rate. But really, because of the compounding or the exponential nature of growth, as I mentioned in class, APR of 6% does not equate to or is not equal to the annual percentage yield of 6%. It's going to be more than 6%. So this is a jargon used by the financial industry, and I know it doesn't make sense. That's probably because the economists and finance people are not mathematicians. What does it exactly mean? So what exactly is meant by APR of 6% compounded monthly is 0.5% every month. Right? Now, if you start with $1,000, how much will you have after 3 years? And so the answer is you take this and multiply that by 1.005. That's 1 plus R divided by K, right? This is what we are talking about. That's the rate per month or rate per period. And now 3 years, you have 12 months. Okay, so basically you have to calculate 1.005 to the 36th power, right? And then you multiply that by 1,000. Okay, now make sure you do this part first and then multiply that by 1,000. Not 1,000 times 1.005. You do not raise that to 36 power. The answer is going to be $1,196.68. Okay, now make sure you know how to calculate this on your calculator before the test begins. Number 3, what are the following formulas used for? This time, yeah, this is called a Jeopardy-like question. I am going to give you the answer or the clue, and you are supposed to come and respond in the form of a question. All right, here's the answer. Okay, if this is the correct answer, what do you think the question was? Okay, well, it looks like $1,000 deposit was made, and P, well, it shouldn't be P. Maybe it should be an A, but that's okay. P is equal to 1,000 times 1 plus 0.005 divided by 12. Why are we dividing 0.05 by 12? Okay, so that's because it's 5% compounded monthly, right? So let's see, what's the best way to write this? This is, what is the amount if $1,000 is deposited into an account with 5% APR, compounded monthly. How do you know it's monthly? Well, because the number 12 is used. And how many years? Well, if you look at the exponent, that's 12 times 3. So that's for 3 years. Okay, so the question, a good question for which this is the correct answer, would be, what is the amount of money that you will have in 3 years if $1,000 is deposited into an account with 5% APR compounded monthly? Okay, next, it's similar. Again, this time it's 0.05 is divided by 4. So what? Let's get rid of this italicized. Right. What is the amount if $1,000 is deposited into an account with 4% APR, compounded? This time it's divided by 4. Why? That's a giveaway. It's basically quarterly, right? 0.05 divided by 4, that's 0.0125, and that is going to give you the rate per period. All right, and the period in this case is every quarter. All right, so compounded quarterly for how many years? 20 years. Okay, and the number 20 is of course right here. 4 times 20 is 80, and that means you have 80 periods on which the amount is compounding. All right, and the last one has this number E. All right, so that is very clear. This is continuous compounding. What? Again, I am going to fix this. Future, what is the amount if $1,000 is deposited into an account with now what? Okay, 0.05, that's 5%. 5% APR, compounded continuously. Why continuous? Because of the number E in there. For how many years? 3 years. Okay, so I hope you understand that these are the questions that would go with these answers or these equations. Okay, I mean, there's nothing wrong with this, but just to be consistent with the notation we use in our lecture, let's call these A, the amount in the future, right? And as we said before, the denominator, okay, this is always K, and the numerator is R, the annual percentage rate, right? And this is also K, and then this number here is the number of years, and that's T. All right, let's go to number 4. You are told that the amount of your monthly payments for a new 30-year mortgage is $1,800. So this is your deposit D or monthly payment. Calculate your total payment over the 30-year period. Are we missing anything? Am I supposed to have like the interest rate or something? Well, no, not really, because as soon as you know, I mean, this, you don't have to calculate this, right? Sometimes for your homework, you needed to calculate this amount based on your interest rate and the amount of mortgage. Well, the amount of mortgage is not given here, but that's okay, because all you need for the total payment or the total amount of payment, is your monthly payment times how many months you have in the year, and it's 30. This is 360, and that's because you are making a $1,800 payment 360 times. That's how you buy your house on a 30-year mortgage. That's going to be a relatively cheap amount. Anyway, if you multiply these numbers out, you get $648,000. That is your total payment. Now, what else do you need to know if you want to find the total interest paid over the 30-year term? Well, this is your total payment. Okay, what you need is we need the amount amount borrowed, amount of the loan. How much was this mortgage for at the beginning? Okay, and what you have to do is let's say that amount is your amount is P. Okay, then P minus, oh, I'm sorry, because $648,000 is going to be the bigger of the two values. So 648,000 minus P is the interest paid, total interest paid. Remember, the total interest paid is simply the difference between how much you actually paid and how much you borrowed. Okay, so that's pretty simple. You do not need to know the rate. Okay, number 5, if the principal or the initial deposit is 5,000 and the interest rate is 4%, calculate how much you'll have at the end of 1 year if the interest rate is compounding annually. In this case, it's 1.04 after 1 year, and that's all you have to do, 5,200. Okay, monthly. If it's monthly, even at the same rate, say you have 0.04 divided by 12, multiplied by 12 times 1, and that's because you have 12 months in the year. And again, make sure you do this part first, and if you do this calculation, you will get $5,203.71, slightly more than the annual compounding. And by the way, the difference is very little, and that's because you only have 1 year as your term. If it's 30 years or 50 years, the difference would be rather significant. Continuous compounding, this is 500 times E, remember, and then you multiply, the exponent to E is 0.04, that's your R, the APR, times the number of years, which is of course 1, right? So you calculate this part first, and you multiply that by 5,000, the answer would be slightly more than the monthly amount, $5,204.05. And of course, notice here that continuous compounding gives you the most amount. All right, so that's been the first 5 questions. The next 5 questions will be covered in part 2.